Here's another pair of binomials that we're multiplying. And remember, when we multiply binomials, we use our FOIL method. The f of FOIL says take the first one here times the first one here. 5x times 5x would be 25x squared. X times x is x squared. 2x is being multiplied. That's x squared. The O of FOIL says take the outside terms. 5x times minus 6. 5 times minus 6, that's negative 30, so we get negative 30x. The I of FOIL says take the product of the inside two terms. Plus 6 times 5x. Plus 6 times 5 is plus 30, so that gives us plus 30x. And the L of FOIL says take the product of the last term in this binomial times the last term in that binomial. Plus 6 times minus 6, a plus times a minus is a minus. 6 times 6 is 36. And look again at what happens. Minus 30x plus 30x, that disappears into 0, just leaving us 25x squared minus 36. The second example of where the product of two binomials gave us a binomial. And if you recall what the other problem looked like, what's interesting about these, and if we look at it here, notice that the terms in the binomials are the same. 5x, 5x, 6, 6. One is plus, one is minus. Anytime that happens, you're going to have those middle terms disappear, leaving you just a binomial as your product. Let's look quickly at another example of that. If we had this situation, 2x minus 5 times 2x plus 5. The first terms in both binomial are 2x. The second terms are both 5. One is a subtraction, the other one's an addition. This fits that special pattern because the f of FOIL is going to give us 4x squared. The O of FOIL would give us plus 10x. The I of FOIL would give us minus 10x. And the L of FOIL would give us minus 25. And once again, those terms combine to 0, just leaving us 4x squared minus 25. So whenever you see this pattern, the first terms are the same, the second terms are the same, one is subtraction, one's addition. It doesn't make any difference the order, which one's first, subtraction or addition. It's always going to be the answer of the square of this minus the square of that. This is sometimes called the difference and sum of two terms. And when you take that product of the difference and sum of two terms, you always get the difference of the squares of the terms. We always get the difference of the squares of the terms. And so this is one of our special products when we're multiplying binomials that crops up from time to time.